Hello Year 9s, welcome back to Math and Magic. In this video we're continuing with our topic of linear relationships, and what we are doing today is we're looking at finding the equation of a line. So by the end of today's lesson, there's two things we want to be able to do. We want to be able to find the gradient and y-intercept of a line, and also write the equation of a line in the gradient-intercept form. That's the two things we're going to do. Now this lesson is actually going to pull together a lot of the stuff that we've looked at throughout this topic of linear relationships, and in order to do finding the equation of a line. So I need you guys to think back to some of the earlier lessons that we had in this topic as well. So before we do that, let's actually do a quick recap of what we've done in this topic. And in particular, I want to draw your attention to a few things that we've done. In this topic so far, we've actually looked at graphing a whole bunch of linear relationships. And so what we did was we first started off with plotting points on the Cartesian plane. So for example, let me just draw a better Cartesian plane. How about that? Okay, here the first way that we did this was we plotted a whole bunch of points on our Cartesian plane like this, and then we drew a line through it. So that was at the beginning of this topic where we were trying to sketch a linear relationship by plotting points on a Cartesian plane. That was the first way that we drew our linear relationship. Then from there we actually did, okay, well, we can actually find our intercepts, and from finding our intercepts, if we get two intercepts on our Cartesian plane, we can draw a line through it. So we could find our x and y intercept by subbing in y is equal to 0 and x is equal to 0. And once we've done that, we actually were able to draw our linear relationship on our Cartesian plane like this. The third way that we did this was, most recently, we talked about the gradient-intercept form. And the gradient-intercept form tells me the two things, the gradient of my line and also the y-intercept of my line. And so if I could get the y-intercept, I can put it on my Cartesian plane like here. If I can find the gradient, that means I can get another point on my Cartesian plane like that, and then I can draw a line through it. So those were the three ways that we actually drew linear relationships on our Cartesian plane over the course of this topic so far. Now, what we did for all of these was we were given an equation. So we were given, for example, y is equal to mx plus b, and we got given that equation, and we were actually able to find the linear relation, draw it on our Cartesian plane. What we want to actually do in this lesson is we want to actually go from being given the equation to actually finding the equation. So we want to be able to go, okay, maybe I've been given a line like this one here. What is the equation of this particular line? And so that's what we're going to be looking at in this lesson, actually working backwards to finding the equation of our line. And so here, the way that we need to do this is we want to actually write this in gradient-intercept form. And so if we want to write the equation of a line, we actually need two things. We need two things, which are the two parts of my gradient-intercept form. I firstly need my gradient. So I need to find a value for m. So if you remember, the gradient-intercept form was y is equal to mx plus b. So we need to find the gradient, and there's a few ways that we can do this. Now, if you remember from when we looked at the gradient, we actually use the equation for the gradient being equal to rise over run. And so we can find the gradient by using this formula, or if you get given 2 points, we also use the formula y2 minus y1 over x2 minus x1. And so we use these formulas to help me find the gradient. So we're going to need to also apply this in today's lesson as well. The other part is b. b is my y-intercept. And so if I can find these two pieces of information, then I can sketch my linear relationship on my, I can actually find the equation of my linear relationship. So here's a few steps that I want you guys to follow if we are doing that. So here's the steps for finding the equation of a line. First step, write the gradient-intercept form. So no matter what the question is, what I want you to do is just to write y is equal to mx plus b. That's just starting step. And so from here, you're going to go, okay, I need to find m and I need to find b. It tells you that you need to find m, you need to find b. You need to find numbers to replace m and b in your equation, your gradient-intercept form. Okay, the second step is then we want to find the gradient of the line. And so here, when we're trying to find the gradient of the line, what we're doing is we use that formula that we have up here, rise over run, or if they give you the gradient of the line, we can just sub it in. So here, once we found the gradient of the line, we're going to substitute it into where m is. So we're just going to replace m with our gradient that we find. The third step is then we want to find the y-intercept. And then we substitute it into b. So we replace it into b. Now there's a few ways that you can find the y-intercept. So depending on the question that you have, the first way that you can do this is just read it off the diagram. If on your diagram, they include the y-intercept. So for example, if they show you a diagram and the line that they have here passes through the y-axis and they tell you what this point is here, so let's say it's -3, all you need to do is just put that into b. So we just read it off the diagram. However, the other way that we can also do this is if they give you a point, so let's say they give you a point on your line, so like 1, 9 or something, we can substitute a given coordinate into the line. And so we can sub it into our equation after we've subbed in our gradient, and that will help me find the y-intercept. I'm going to go through how to actually do both of these examples, so reading off a diagram and also substituting a point and helping us find the equation of a line. So we're going to go through a couple of examples to do this. So let's have a look at this first one here. Finding the equation of a line given a y-intercept in the point. So example 1, determine the equation of the straight line shown here. Okay, we have a line here, we have a diagram for a line, and we get told, and if you have a look at the diagram, we've got an x-intercept at -2 and a y-intercept at -4. So the y-intercept at -4 will actually help me in figuring out the value of b later on, which is exactly what I want. And it's quite easy and nice for me to do for this question. But like I said in the steps, the first thing I want to do is I'm just going to write the equation of the gradient intercept form. I'm just going to write y is equal to mx plus b. I'm just going to write that in no matter what the question is. If I'm trying to find the equation of a line, I'm just going to write the gradient intercept form. Okay, now that I've done that, I'm going to try and find the gradient. Now on the side here, I'm just going to do my working out for finding the gradient. I would recommend you also do this as well. Now the gradient is just the rise over the run. Now in this diagram, we can actually find the rise over run as well. So here, I'm just going to write rise over run. And if you remember, the rise is how many vertical units we need to get from 2 points. Now, if you have a look, we've got these 2 points, the x-intercept and the y-intercept. What I can do for the rise is I'm noticing that here, I'm going down from, I'm reading it from left to right. I'm going downwards. How many units? Well, there's 4 units here. So this is a rise of -4. So here, I'm going to have a rise of -4. I'm going to divide that by the run. Now, the run is the horizontal units. And here, I go across by, from -2 to 0, that's 2 units. So here, this is going to be -4 over 2. And so when I simplify that, that gives me -2. And so what that means is that I can substitute -2 into my gradient here. So I'm going to have -2x plus b. That's the first part. So we've wrote down the gradient intercept form, and then we also found the gradient and substituted it in. So that's what I've done here. I've just replaced m with -2. Now the next part is we want to find the y-intercept. Now here, what I said earlier was the y-intercept was already given to us. It's -4. So I'm just going to have b is equal to -4. And so for my equation, I'm just going to write -2x plus -4. And we're almost done here. We just need to fix this up a little bit just to make it a little bit cleaner. And so here we've actually, that step, we read off the diagram what the y-intercept was. So b was equal to -4 and we just substituted it straight in. Now here, when we're adding a negative number, we don't need to write that plus minus here. So I'm just going to rewrite this as -2x. If I'm adding a negative number, that's just the same as subtracting it. So here, my final answer is going to be y is equal to -2x minus 4. Okay, so let's just quickly sum up the steps I did here again. First step, we want to just write down the gradient intercept form. Y is equal to mx plus b, which is what we did in this first line. So this is our first step. We want to write down the gradient intercept form. Then the second step is we want to find the gradient. Now, if they don't give me the gradient, I need to actually find it using my rise over run equation. And then once I've done that, I'm going to substitute it in to my equation, into my gradient intercept form, where I see m. Okay, then from there, My third step is I want to find the y-intercept. In the diagram, they give me the y-intercept, which is really nice. So once I've found it, all I need to do is just substitute it into where b would be in my equation. And then final step that I did here was I just cleaned it up, made it a little bit neater looking. So that's how we find the equation of a line if we get given a y-intercept and a point. Okay, that's the first example. Excellent. Let's have a go in another example where we might not be given the y-intercept. For this example, we got given the y-intercept, which was really great, but sometimes you're not going to be able to you're not going to be given the y-intercept immediately. So let's have a look at this example over here. Finding the equation of a line given a gradient and a point. So for this example, they tell us what the gradient is. And what we need to do is we need to actually use that gradient and an additional point to help me find my y-intercept, so that value of b. So let's have a look at this example. Find the equation of the line which has a gradient m is equal to 1/3 and passes through the point 9, 2. Now notice here we don't have a diagram, but that's totally fine. We can actually find the equation of this line using the information we have here. So let me just underline a few key pieces of information. The line has a gradient m is equal to 1/3. Okay, and it also passes through another point, 9, 2. So we have this point and the gradient. So we've got the gradient, we have this gradient of 1/3 and we have this point at 9, 2. So regardless of what question you do, if you're trying to find the equation of a line, we start off by writing the gradient intercept form. So y is equal to mx plus b. Okay. First step after we've done that is then we want to find the gradient. Now here they actually tell me in the question that the gradient is equal to 1/3. So m is equal to 1/3, and all I'm going to do is I'm going to replace m in my gradient intercept form with 1/3. So here I'm going to have 1/3x plus b. I'm just going to write y here for that. So that's the first step. I've just substituted my gradient into my line. Okay, now here the second part is that they tell me that we have a point 9, 2. So I'm going to write here, I've got this point 9, 2. If they give you a point, what you need to do is you need to substitute it into the equation that you have. So I want to substitute it into this guy here after I've put in my gradient, and then solve for b. So if I get given a gradient and a point, unfortunately I need to do a few extra steps to actually help me find that value of b, that y-intercept. So when I substitute this, let's just identify what we need to do. Well, we need to substitute our x value and our y value. In our coordinate, our 9 is our x value, and our 2 is our y value. So what I'm going to do is I'm going to substitute 9 for x and 2 for y. So here I'm going to do that in the following step. So here y is equal to, so on my left hand side I have y, so I'm going to write 2 is equal to 1/3 times 9 for my x value plus b. Okay, and now that we've done that, we're just going to slowly work through this and solve for b. Now on my left, let me just deal with that fraction first. So I don't quite like fractions. So here I've got 2 is equal to 1/3 times 9. 1/3 of 9 is just 3 plus b. Okay, and I'm going to solve this. Now I want to have b by itself, so I need to move this 3 over to the other side. And if I move it to the other side, I'm subtracting. So here b is going to be equal to 2 minus 3, which will just give me b is equal to -1. Okay, now that I've got a value for b is equal to -1, all I need to do is just substitute it back into my original equation that I had up here with my gradient. So therefore, my equation of my line is going to be 1/3x minus 1. So that's how we find the equation of the line. Once again, same steps. Write down the gradient intercept form, find the gradient. Now in this case, we actually get given the gradient, which is really easy for us to just plop it straight into our gradient intercept form. Then from there, we want to find the value of b. And for that part, we actually needed to start solving. We needed to substitute our point. So here we substituted our point, and we noticed that the x value was 9, the y value was 2, and we substituted it into my equation. And so I substitute those x and y values in, I solve for b, and then I put that back into my gradient intercept form line that I had earlier. Okay. So that's it for today's lesson. Let's just quickly sum up what we did in today's lesson. In today's lesson, we were looking at finding the equation of a line in using the gradient intercept form. And here, what we needed to do was we noticed that we need to actually find two things. We need to find the gradient and the y-intercept for my line in order for me to write the equation. And we followed those 3 steps. Write the gradient intercept form, find the gradient, find the y-intercept. So that was the 3 steps that we followed. And we did that with two different examples. The first one, we got given the y-intercept on a different point. So we had to firstly calculate the gradient and then put in our y-intercept. And the second example, we were given the gradient, but then we had to substitute our point in it. And so here we put in our gradient, but then we had to solve for b. So that's how we find the equation of a line using the gradient intercept form. As always, if you're unsure about anything, feel free to leave a comment or send me an email. I'm more than happy to try and answer your questions. But until next lesson, Year 9s, I hope you guys are staying safe wherever you are, and I will see you in the next video. Bye!